And in this part, I would like to show you some functional forms of regression models. Here on this slide, I've mentioned 5 of them, but actually there are many more. But I think those are the basics ones that you must be familiar with. So let's go through this functional form one by one. So let's start with log linear model. So the log linear model. Let's start with the following exponential regression model. So y is a function of beta 1, xi taken to the power of beta 2, and e taken to the power of the error term. By taking the natural logarithms of both sides, we can get the following expression. So ln y is equal to ln beta 1 plus beta 2, right? So we move the coefficient up front, ln xi plus the error term, right? Because ln e is equal to 1. Or we can do a small replacement. So instead of having ln beta 1, we can just have alpha. So ln y is equal to alpha plus beta 2 ln xi plus the error term. So such a model under number 8 or even number 7 is called log-log model or double log model or log linear model. So this is the kind of model where both the dependent and independent variables are expressed in logarithms. So once again, a log-log or double log or log linear model, this is the type of model in which both the dependent and independent variables are expressed in logarithms. When it comes to the slope coefficient interpretation, it is the following. So a 1% change in x, all right, so 1% change in x is associated with a beta 2% change in y. Right, so when x increases by 1%, y changes by beta 2%. So since beta 2, and because of that, we can say that actually what beta 2 is, this is the elasticity of y with respect to x. So this brings us back to the definition of elasticity, right? So when one variable changes by this many percent, the dependent variable changes by this many percent. So in case of this expression, when x increases by 1%, y changes by beta 2%. And here I've put a cautionary note that you must remember. So please be aware that there is a big difference between percent change and percentage point change. So for example, the unemployment rate is often expressed in percent form. Say the unemployment rate is 6%. So, and if this rate goes to 8%, we say that, and now the important part, that the percentage point change in the unemployment rate is 2, right? It increased from 6 to 8, so the percentage point change is 2, whereas the percent change in the unemployment rate is calculated in the following way, right? We take the new value of unemployment, we subtract the previous value of unemployment, and we divide by the previous value of unemployment, so we get that the unemployment rate has increased by 33%. So once again, percent change and percentage point change are not the same things, and this example shows it clearly. So when we say that the unemployment has increased by 2 percentage points, then it means that it literally changed from some number 6 to some number 8. However, if we say that the unemployment rate has increased by 33%, then we know that probably some sort of formula has been used to calculate this percent change. So in our case, what we have here is percent change, not percentage point change but percent change. So when x increases by 1%, y changes by beta 2%.